So we're diving into some pretty deep stuff today. But instead of like dodging bullets and stuff, we're tackling Linux permissions.
Yeah.
You've got this Linux Basics for Hackers PDF.
Right.
And before you think, wait, I'm not, building some kind of digital heist crew here, trust me, this stuff is like the secret code to understanding how your computer actually works.
Yeah. It's like having X-ray vision into the control panel of your own system.
Okay.
And yeah, just like the title suggests, it's a fundamental part of cybersecurity,
Right.
whether you're on offense or defense.
Okay, so the document jumps right into controlling file and directory permissions.
Right.
Honestly, doesn't sound super thrilling on the surface.
Right.
But then it hits you with this idea of not every user on a system should have the same access.
Yes.
Like you wouldn't hand out keys to the company vault on day one.
Right. Exactly. Linux was built for collaboration. Multiple users, even automated processes needing access. Permissions are how it keeps everything from descending into total chaos.
Okay, so what are these mystical Linux permissions? The document lays out three main ones, right?
Yep. Read, write, and execute. Think of a physical file read. Means you can peek inside. Write is like grabbing a pen and making changes. And execute. That's the fun one. If the file's a program, you get to run it.
Okay, I'm with you so far. But then it gets a bit more granular, right? It's not just, can something be done to a file? It's WHO has the authority.
Right. On Linux has this hierarchy.
Yeah.
Just like a well-organized team.
Yeah.
You've got the owner, they call the shots.
Yeah.
Then there are groups, kind of like departments sharing access.
Yeah.
And finally, there's everyone else, the general public of your computer.
So it's like setting different clearance levels for your files.
Precisely.
Top secret, need to know basis,
Yeah.
that sort of thing.
Precisely. And here's where those cryptic code strings come in. The document gives us an example, a file called hashcat.hcstat.
Oh, boy.
Now, before you worry, we're not cracking passwords today.
Good to know. I was about to change all my passwords just in case.
But the point is, when you look at this file, you see this string, RWRR. This isn't gibberish. It's a direct map of who can do what.
Okay, because I was going to ask, that looks like something out of the Matrix. How do we even begin to decode that?
It's actually quite elegant. Remember our three permission types, read, write, execute,
Yes.
and our three user types, not or group everyone else. That string lines them up perfectly.
All right, break it down for me. We've got RWSEA at the beginning. So that means the owner can read and write, but not execute this file.
You got it. That dash is where an X would be if they had execute permission.
Okay.
And then the R repeats twice, meaning both the group and everyone else are limited to just reading that file.
Wow. So what seemed like random characters actually tells a whole story about who's got the keys to what. That's pretty wild.
And that's just scratching the surface. What's fascinating is that Linux starts with surprisingly open permissions by default. 6666 for files and 777 for directories.
Wait, really? That sounds a bit like leaving the front door open and hoping for the best.
It might seem counterintuitive,
Yeah.
but it goes back to that core idea of collaboration. Linux assumes you'll lock down what you need to, rather than starting with Fort Knox. And that's where things get really interesting, as we'll see in part 2.
All right, so last time we cracked the code of those like cryptic Linux permission strings. We know what they mean. We know who's got the keys to the kingdom and all that.
Exactly.
But now I kind of want to get my hands dirty here.
Yeah,
The document talks about this command chmod.
right.
What is that?
So chmod is the master key.
Yeah.
The control panel for tweaking those permissions.
Yeah.
It stands for change mode. And it's your secret weapon for adjusting who can access what.
Okay. So we're going from like observer to operator now.
Yes.
I like it. How do we use this chmod though?
So there are two main ways to do it. One is the numerical or octal method.
Okay.
It's like using a secret code. But once you get the hang of it, it's super powerful.
Ooh, secret code.
Yeah.
I
So
like-
imagine a 3-digit code where each digit represents read, write, and execute permissions for a specific user type. So for example, if you wanted to grant all permissions to the owner in the group, but only read access to everyone else, you'd use 774.
Okay, so 774 is like a code for full control for the owner and the group,
Yes.
but only read for everyone else.
Exactly. Each digit represents a combination of those three permissions. It takes some getting used to, Yeah. but it's very efficient once you grasp the logic.
Okay, I'm starting to feel like a Linux ninja master here, but you said there was another way.
Right. The symbolic method, also known as UG, for user group others. It's more intuitive for some, because it uses simple symbols to represent what you want to do.
So instead of a secret code, we're using plain English, kind of.
Exactly. So you use U for user, G for group, and O for others. Then you'd use symbols like to add a permission, to remove one, or to set a specific permission.
So like UX to give the user execute permission?
Exactly.
Or like GW to remove write permission from the group?
You got it. It's all about specifying who you're targeting and what you're changing.
Okay, I like it. So the document uses an example that I think illustrates this really well. It says, imagine you download a new tool for, let's say, analyzing website traffic.
Right.
When you download it, it might not have execute permissions by default.
Right.
How do we fix that?
Right. That's common. Linux often sets default permissions to be more secure.
Okay.
So you'll likely get a permission denied error if you try to run the program.
Right.
But we know how to fix that with TrueMed.
Right. So we'd use TrueMed to grant ourselves execute permission.
Exactly.
Got it. And there's this other thing called a mask.
Right.
What is that?
So mask is like a pre-configured setting that defines the default permissions for new files and folders. It's a safety measure, but it can sometimes be a bit restrictive.
So it's like a template for how new files are set up.
Exactly. It helps prevent unintended access,
Yeah.
but it's something to be aware of, especially if you're working with downloaded tools.
Okay.
Think of mask as a gatekeeper,
Hmm.
but it's something you can also change to make things less restrictive.
Okay. Cool.
Hmm.
And all of this is really setting the stage for our next episode when we're going to talk about how hackers can actually exploit all of this.
Yes, exactly.
So definitely tune in for part 3. It's going to be a wild ride. All right. So we've made it to the danger zone, I think.
Right.
We're going to put on our, metaphorical black hats and see the world through the eyes of a hacker.
Right. Because to understand security,
Yeah.
you have to understand how to bypass it, right?
It's true. Knowledge is power.
Right.
So where do we even begin with this whole hacker mindset thing?
Right. Well, remember how we talked about Linux starting with those surprisingly open permissions by default? 666 for files, 777 for directories.
Right. Yeah, like leaving the door unlocked and hoping for the best.
Right. Exactly. And while it's rooted in that Linux philosophy of collaboration, it also creates vulnerabilities.
Right. So a hacker gets into the system and it's kind of open season in a way.
Yeah, and it goes deeper than that. Hackers are always looking for ways to escalate their privileges, to go from a regular user to basically having full administrative control.
It's like finding a back door into the control room and you can suddenly change all the rules.
Exactly. And one way they do this is by exploiting special permissions, specifically SUID and SGID.
Okay, remind me what those are again?
Right. So SUID, which stands for Set User ID,
Yeah.
allows a program to temporarily borrow the permissions of the file owner,
Okay.
even if that owner is root.
So it's like handing your ID card over to someone so they can get into a restricted area.
Exactly.
Except in this case, it's the whole system.
Right. And SGID, or Set Group ID, does the same thing, but with group permissions. Now, these mechanisms exist for legitimate reasons, like letting users change their own passwords, for example.
Right.
But in the wrong hands, they can be exploited.
Yeah. It's like those master keys we were talking about earlier. You need them sometimes.
Right.
But yeah, scary in the wrong hands.
And this is where things get really interesting from a hacker's perspective,
Mm-hmm.
because our document actually highlights a tool called Find that hackers can use to locate files with the SUID bit set.
Oh,
It's
okay.
like they're scouting for those master keys.
Got it. So by understanding these special permissions, a hacker could find a way to exploit them, to get access they shouldn't have.
It's all about connecting the dots.
Right. And that's why it's so important for like the average person to understand this stuff.
Right.
Because it can really, we're talking about really the fundamental security of a system here.
It's not just about managing your own files.
Mm.
It's about understanding how those security measures can be circumvented.
Yeah. And I think this document does a really good job of illustrating that.
Yeah.
So we went from these cryptic code strings to understanding how they can be manipulated and even weaponized.
Right. And that's the power of knowledge.
Right.
Yeah.
So the next time you download a file or install some software, think about those permissions. What access are you granting and to whom?
It's like doing a mini security audit on your own computer.
Exactly. Well, this has been a wild ride. I feel like we've gone really deeper.
Gone down the rabbit hole.
Yeah.
Hey.
Very informative. So thank you for, guiding us on this journey.
Yeah, of course. It's been fun.
And for everyone listening, we'll catch you next time for another deep dive.